These all activities are of course done in the Harmon schools, but what I'm going to talk is an additional and optional activity, and I cannot give a name for this one. But what I can simply say that we tried, it works fine. With the balloons and the other activities.
Mr. Sakar, if I may interrupt you here, please.
Okay.
Okay, so it's really interesting that our school, our campus is actually fairly new, so that means our fire marshal can leave around 4 p.m. because all the students have left. But we were so enthusiastic about building our bridges and being in this creative environment that we want to stay till about 7 p.m. And unfortunately, that meant our fire marshal had to stay too, but I'm sure he didn't mind too much, because it was really fun.
And the last picture. Number 4, so number 4, coming here.
We first selected best design competition. But they really enjoyed, so I want to invite one of those ninth grade students. She was ninth grade, Nancy, to the stage and to explain what she was doing.
Hello, and good morning. And over here is something that I love playing with, and this is actually called the Popper Dropper. Now, me and my friends over here are just gonna show you guys how this works. So let's get ready, guys. Okay. 1, 2, 3. Now, can anybody tell me how many potential energies are in the Popper Dropper? Yes, they are actually correct. There are 2 potential energies that are in the Popper Dropper: gravitational potential energy and elastic potential energy. And these 2 potential energies are converted into linear kinetic energy. And because you have that extra added on elastic potential energy inside the Popper Dropper, it makes it to bounce higher than an average ball, no matter what height you put it at. So thank you very much for that. Thank you guys. Okay, hello, my name is Nancy Osazua, and last year I was one of 35 ninth graders who participated in the physics projects. Now, being a ninth grader and being used to the environment and taking classes and just knew everything, it was pretty challenging to have to balance physics projects on top of that. But because I was physically and intrinsically motivated, I was able to persevere throughout all my challenges. And it wasn't all hard work. I had a partner by my side who was with me the whole time. And I can still remember that we had to make a video presenting our project, actually. And in this video, we had to use physics terminology. Now that took me way out of my comfort zone because I felt like I was speaking a foreign language or something. It was really different, especially being a ninth grader. But because I had Mrs. Sakar and all the teachers and my peers and my partner who were supporting me, I was able to learn these physics terminologies and be able to present them, like I did to you guys right now, clearly and efficiently. It's not all hard work, actually. It was really fun. We got to present in George R. Brown and in Austin, and because I was a ninth grader, physics wasn't a required class for me yet. I still had to wait till 11th grade. But because, like I said, I really wanted to do it, they were able to work with me and take me seriously. And I was able to learn more and more efficiently than I would have in a classroom because I was not scared to ask a question. It was me and my partner. And not only did I learn my own terminologies from my own project, I learned other terminologies from all my other peers' projects as well. And that really helped me. And I feel that when I go to 12th grade and I want to participate in AP Physics, I'll be able to know a lot of terminologies. And as a 10th grader right now, I'm currently participating in the chemistry project, which has to do with using paper chromatography to break down homogeneous mixtures such as black, the color black. So I want to thank you guys so much for listening, because this is very important to me, of course. And I hope you have a nice day. Thank you.
Okay, thank you. The most famous hovercraft in cosmos.
Hello, my name is Sergio Mendoza, and I'm one of the 4 who built the most famous hovercraft in Cosmos, and well, which was even published in the media. And well, I have presented this project more than 30 times in front of the mayor of Houston and state representatives. And some of y'all may have already seen it yesterday in stage and maybe in the STEM Expo. And the reason why it hovers is because the coefficient of force of friction of air is less than the coefficient of force of friction of the ground, which makes it hover. And as he said, last year I was taking regular physics instead of pre-AP physics because I was so scared of physics. And as I started to interact with projects and construct them myself, I began to notice that I can understand the most hardest topics in physics. And even I can teach it to my classmates and evaluate their knowledge. And now I'm taking AP physics. And well, I'd like to thank all my teachers for giving me the opportunity to interact with the projects and letting me do them by myself. And now that really helped me and it motivated me to take AP physics. And well, as you can see, no child left behind in Harmony School.
Right, last year, 1/3 of chemistry classes and 1/4 of physics classes choose AP physics. So what we see is that by making hands-on activities, if the students are presenting on their own, they are too much engaged and they don't want to give up studying physics. They want to continue with the physics. So there's only one way to continue with the physics, to take the AP course. Okay, so who is coming next? Okay, yes, Daniel is coming next. Daniel.
Hello, my name is Danielle Bailey. I'm a senior here at Harmony Science Academy. I was born in Baltimore, Maryland, and some would say...
It's better that you are louder. Can you...
Hello? Better? Okay, good. Like I was saying, I was born in Baltimore, Maryland, and some would say it's a pretty rough town to live in. And growing up in that environment, I grew to be an overly serious person. So that means that everything that I had to confront, I confronted too sternly. But one thing that I gained from being able to be taught through Harmony's curriculum and being able to teach to my fellow students what I have been taught is that not everything is serious and that even the most daunting principles of physics can be fun. So we have 12 categories of scientific demonstrations, but for courtesy of time, I'm only going to show you 3. And so, but I think the coolest thing about this project is that real butterflies, they only live about a week. Harmony butterflies live forever. So
this is a different category actually. This is a decoration category. So we have regular decoration materials in which we are using in science. And I may give that butterfly to the... So that just to show that it's not a real butterfly. Okay. So it enjoys when you look at it.
Another thing that we use momentum, and we learned that once a object is released and it has a constant magnitude and direction, that it tends to do such until acted on by an external force, which in this case is gravity. We also have here.
Okay, let's go all together.
We also have here Harmony's helicopter balloons, and we use this to learn about. You guys, can you join me?
Okay, this is another type of category, the classical toys that we are using in science.
Yes. So you guys, what's the principle here? What? Yes, that's right. Newton's third law is that. Yes, you're right.
Yeah, both of them. I mean, it's not only Bernoulli's principle, but also
Newton's third law is that for every action there's an equal and opposite magnitude reaction force. And Bernoulli's principle is that as the speed of a fluid, be it liquid or gas, increases, the pressure within that fluid decreases. So we have that. Then also we have here our thunder tube. Mr. Sakar, we're about to do the things. So. Okay, so what's the principle here, you guys?
amplification.
Not you, Sakar, the students. What? Okay, good. And then lastly, we have here our duck in the cups. So if you guys will.
Right, let's do it with the movie, okay, now that our sound is working fine.
And what's below you, incredible? Hit from the step and just turn.
Slow. So lower frequency, lower pitch, higher. More, more.
When I move the straw closer
So,
to
how the musical instruments work is a difficult
pitch
topic.
higher.
They have to learn combining harmonic frequencies. Nobody can sleep, even the...
Let's take a look at the duck cup. When I pull on the string, the sound travels to the cup. And
Are you ready?
exciting science and fantastic schools. Thank you for watching Harmony Does.
So as you can see, when a classmate is teaching the students versus the teachers teaching them, they have no time to sleep at all because they're engaged in what they're actually doing. And this benefits them when because they're learning a different way to think and to comprehend. So versus them learning from a blackboard, they're actually being able to learn how to be engaged in all aspects of life as well as science. So thank you.
Okay, thank you, Nelly. So by the hands-on activity, they are all the students are doing. I mean, this is a different category. Not one student is presenting, the others are listening. In that category, all of them are doing it, so nobody can sleep in our class. And even some of the teachers beside class, they are also coming, what's going on, and they visit us. So by this way, we will be able to use the multisensory approach to the students. Now, who is coming next? Yes. Just me, you can come. Right?
Hello everyone. So first I'd like to show you my demonstration. This is a chemistry demonstration talking about chemical changes when two different elements combine that have different pH scales and acidity levels. So what I've already put on these white carnations that are fake is phenolphthalein. Phenolphthalein is my indicator, and then I'm going to use ammonia solution, which is my base. And when I spray it, I change its color. And there's no pink in here. It's a clear liquid, and it's not magic, it's science. This one is the golden rod paper. It works the same way. If I put ammonia solution on my hand, clear liquid again, and put it on the golden rod paper, it's red. Still science, not magic. They both work the same way. Also, due to the carbon dioxide in the air, the color actually fades away. So I've been using this paper yesterday if you came and stopped by my table, as well as last year in our other presentations. So this year I'm working on a physics demonstration. However, last year I worked on chemistry demonstrations where I was one of the 50 students working on chemistry demos. I not only learned my own topic, but I learned the other 50 principles as well. So it was kind of like having 50 other teachers around the school and like learning everything, so that way if we learned a topic in class, I was like, oh, I know that, she did that project. We not only presented to our class, but we presented in a little competition that we had after school, which the pictures are up here from the PowerPoint. And we competed against each other. We just had to learn. We learned our topic and made sure we were able to explain so that we were prepared to present in the I-SWEEEP Public Day, which Mr. Sakar had also talked about, where we presented to kids and adults of over 2,000 people, 70 different countries, and 40 different states. We've also presented in the Austin Capitol to the Honorable State Representative, and we also presented to VIP guests, including Dr. Rod Page, who's also the 7th Secretary of Education, the U.S. Secretary of Education. We've also presented to the mayor, the media. We've also presented to people from companies and organizations.